Yeah, we can use the TF-IDF. If you still remember, we use the TF-IDF, which is the term frequency inverse data frequency. And we use this one to check the frequency of the words in a document. Let's say we have this one, the car is driven on the road and the truck is driven on the highway. So we can use just kind of factor. This is to represent the frequency. Okay. So we can see the frequency for every of the word. And then after we have this frequency, we can do the calculation for the TF, which is the term frequency. And then we can do the IDF, which is the inverse document frequency, to check the frequency of that particular word in the document. And then finally, we just multiply between the TF and IDF. Now we can go to the next section, which is how to mine the World Wide Web. So www, we call it www, it is from the web. If you access any web, then of course you can see the word www. So if you have this one, like www.naver.com. So this is the web. Yeah? This is World Wide Web. So every of this web will start from the www. And if you want to mine any things from the www, it is very huge, widely distributed, and it is a global information service center for the information services. The information services means, we can use it for news, or we can use it for advertisement, consumer information, financial management, education, government, commerce, and etc. And we can use the hyperlink. So hyperlink, it means we want to link the information from one web to another web. And we can also see the access and usage information. It means when you access a news web, so you can we can see when you access the web, what is the content, and etc. So www provides resources for data mining. It means you can see where you access, when you access, from which computer you access, what are the browser that you use to access the web, and etc. And the challenge is it is too huge for effective data warehousing and data mining. So when you do with the data warehousing, if you still remember the data warehousing, we are making a warehouse for data. But the www is too huge, so we cannot make it with the data warehousing. And the data in the web is too huge, it's too large. So it is a very high challenge for the data mining. And it is too complex and heterogeneous. The data is no standard and there is no structure. So if you look at the web search engines, in the web search engine, we will learn about the index page. What is index? Index means when you know a keyword, when you know a search, or you can have the index web page. So it is to build and store huge keyword-based indexes. It is to help locate sets of web pages containing certain keywords. It means when you look at some kind of keywords, for example, if I want to search, let's say I want to search laptop. So it shows many information about the laptop. It shows the e-commerce site for the laptop, and it shows some news about the laptop. It shows about the current laptop. It shows what is the definition of laptop. It shows recommendation of laptop and so on. Okay. So one keyword will give you a lot of set of web pages. The deficiencies is it may be about the topic of any breadth, may easily contain hundreds of thousands of documents. So when I search the laptop, okay, you can see there are so many there are so many documents provide the word laptop. And many documents that are highly relevant to any topic may not contain keywords dividing them. What does it mean? Polysemy, you know? Poly. Poly means many. Semi. So semi means the similar words, okay? Or we call it sometimes synonym. So there are many similar words or there are many synonyms. So if you have this kind of polysemy, it will be very, very difficult to check. So one of the keywords that might give you very difficult to search is about the machine learning. What is machine learning? People already know that machine learning is something related with the data mining. So you can see all those things are related to machine learning, artificial intelligence, and most of the like supervised learning, unsupervised learning, because now it becomes very common. But when you just type machine, the word machine itself, it represents the machine, which is totally different with the word machine learning when it is combined. So machine can have many things. Let's say the machine in the machine shop or machine in the dictionary and etc. So the polysemy means one kind of machine learning. When we make machine learning, it is more related to the data mining stuff. But if it is about machine itself, it is related about the engine, okay, or it is related with equipment. So the word machine can have different meaning. Yeah, when the website have the search engine, it means they are going to crawl. So they are trying to find the existing web, and then they will create an index. After they create the index, and then they will apply to the search algorithm. And after the search algorithm works, so at the end, there will be a result. In the web mining, there are some taxonomy. We can use web mining content or web content mining. So you are going to mine the content. It means we are going to check the web page content. It means the text, document, the text, the document, or maybe some images, or maybe there are some videos. Okay. And we can also do the search. Search means we search what are the available texts in the content, what are the available documents in the content, what are the available images, what are the available videos in the web. The other web mining is about the usage. Web usage mining. It means we can track. What does it mean by track? So we can know how many times you access the website. How many, when did you access the website? What browser did you use to access the website? So it is the general access pattern tracking. If you use Chrome, okay, so they will detect the Google Chrome. Or if you access using the Microsoft Edge, then it will detect with your browser Microsoft Edge. Or if you use any other browser, okay, like Mozilla, then it also can be detected with the browser name. Or if you access with the Android phone, then they will also give you the information. You are accessing the website using smartphone and etc. So there is a general access pattern tracking, but there's also another tracking. We call it the customized usage tracking. So the customized usage tracking means if you are a student, now you are a student at home. So our university also have a kind of patterns to know that if you access to the university website, what will you access? So it is a customized usage tracking for the students. Actually, they also built a new website based on this customized usage tracking. And we can make also the web structure mining. It means if we know the structure, we can mine what are the good structure for our future web. In the web link structures, we want to find the authoritative web pages. Retrieving pages that are not only relevant, but also high quality or authoritative on the topic. Hyperlinks can infer the notion of authorities. So if you know the hyperlink, okay, there is no example of the hyperlink, but the hyperlink can infer the notion of authority. It means the web consists not only pages, but also hyperlinks pointing from one page to another. So like this one. If I look at car, okay, so the car, when I search into car, this website can have a hyperlink to different car company. So this car ranking company, they can go to Ferrari, they can go to Fiat, they can go to Ford, they can go to Honda, they can go to Chrysler. So this is the web with the hyperlink. These hyperlinks contain an enormous amount of latent human annotation. It means when you are clicking in one website, so there will be some kind of, okay, after you click this one, you will click Ferrari. Okay, so there's a kind of sequence. And a hyperlink pointing to another web page, this can be considered as the author's endorsement of the other page. You know, endorsement. It means if I go to the web car ranking of this one, and then I go to the next website, which is Ferrari. So it means I have interest. I have interest on this website. If I have interest on this website many times, then whenever I search a car, the image of Ferrari or the word Ferrari will appear in my browser. So using the idea of this hyperlink, there is one algorithm, it's called hyperlink induced topic search. So it is to explore the interaction between the hubs and alternative pages. Okay, so the keyword is hub and alternative. What is hub? We call this is hub. We call this is hub because it has a link to many different car company. So hub, we call this is hub, something like, you know, the bus terminal. In the bus terminal, it is a hub. And then from this bus terminal, you can go to different direction. You can go to different city. Okay. For example, if you visit the Yongin bus terminal, so from Yongin bus terminal, you can go to Seoul, you can go to Daejeon, you can go to, for example, Jeonju, you can go, for example, go to Busan, etc. So it is a bus terminal. So the function of bus terminal is similar with the hub. And we have the authoritative pages. Authoritative pages means, yeah, it is the authorities. The authorities means the web that represent one company or the web that represent one product. So the hits algorithm, the output will be a short list of the pages with large hub weights. And the pages with large authority weights for the given search topic. It means when I use this algorithm, it will give the hub and it will show the authority. It will show the hub and will show the authority. How? So it will show the large hub weights and the large authority weights. System based on the hits algorithm. The first is some kind of the original search engine like Google, and at the first year, I think in the 1990 something, there was a search engine. The name is Clever. It is to achieve better quality search result than those generated by term index engine. So the term index engine, like the previously, we have the search engine like Alta Vista and also Yahoo. So they use the term index, but the hits algorithm, they try to use the hyperlink induced pixels. So the idea is like this one. To update operations. So V is for the authority. This is V for the authority. And U for the hub. U for the hub. And then we have the A. A is the adjacency matrix. A is the adjacency matrix. Now let's see. I have web number 1, and then I have web number 2, and then I have web number 3. Okay. So given the adjacency matrix of this graph, how can I specify this one? The adjacency, if you know the adjacency means, it is the relationship between the node. Let's suppose I have the index 1, 2, and 3. This is the index 1, 2, and 3. Okay. The web number 1 is connected to web number 3. The web number 2 is connected to the web number 3. Okay. Then the index 1 is connected to number 3. And the index 2 is connected to number 3. And the remaining are 0. Okay. AT, it means the transpose of A. So if it is the transpose of A, then one will be here and the other one will be here. So we have this matrix for the A transpose. Now let's assume that the initial hub width factors is U is 1, 1, 1. Okay, we assume that every of this will have the width 1. Now, in order to check the authority width, what is authority width? Based on this one, V is the authority width. The authority width equals to the A transpose multiplied by U. Okay. U is the operation for the hub. V is for the authority. And you can just fit the data into the formula. V is the A transpose multiplied by U. U is the width of the hub. Then we have, this is the A transpose 0, 0, 0, 0, 0, 0, 1, 1, 0. And then we have the initial hub width. This is the width of U. And what you can look at this one is 0, 0, 2. It means we have the width of the index tree is 2, and this is the authority. Now, let's compute the hub width. The hub width means we will multiply the A with V. V is the authority width. We have this A, it is from this A. And then we will multiply with the V. V is the result from the previous calculation. So we can just apply with the 0, 0, 2. So the result is 2, 2, and 0. So this is the hub width. Okay. It means the node number 1, it has the width 2, and the index 2 is also has the width 2. Then from this width, we can see that the node number 1 and the node number 2, they are the hub. So this is the HITS algorithm. Okay, so yeah, I cannot explain many things about the time series and sequential data, but you can have an idea what is the time series and the sequential data, and also you have some idea how to mine the text data. Any questions until now?